Chemical Reactions, Chapter 7. So here we have a picture of the space shuttle. The space shuttle lifts off because of chemical reactions. In the main engine, we have hydrogen molecules and oxygen molecules stored in a fuel tank, and those react violently. You can see all the energy being given off. And, you know, in this picture, the space shuttle doesn't look all that big, but actually the space shuttle is huge, right? And we've got enough force to send this huge object into outer space. The reaction emits the energy that propels the shuttle into space. So we have this chemical reaction generating lots and lots of energy. Textbook refers to kindergarten volcanoes. They actually don't do these in kindergarten. This is more like a 4th grade volcano. I don't know, he's just a little out of touch. Anyway, you can make a volcano using baking soda and vinegar. Baking soda contains sodium bicarbonate, also known as sodium hydrogen carbonate, and it reacts with the acetic acid and vinegar and generates carbon dioxide gas and water and sodium acetate, and it causes the solution to bubble and foam, and it's, you know, it's safe, and so you can play around with that at home. I never made volcanoes when I was a kid, but we used to have glass soda bottles, and sometimes we'd be able to find a cork that would fit in there, and so you'd put some baking soda and vinegar in the soda bottle and put the cork on it and wait, and the pressure would build up and the cork would go flying. And you know, it was just really, really fun. What is a chemical reaction? It's the transformation of one or more substances into different substances. In the reaction that causes the space shuttle to lift off, we have oxygen molecules and hydrogen molecules combining to form water. The oxygen and hydrogen gases are not present anymore. They were destroyed, and water was created. In this kindergarten volcano reaction, we have baking soda and acetic acid reacting and forming new compounds, and that's what a chemical reaction is. The kindergarten volcano is an example of a reaction that is called a gas evolution reaction. It's occurring in a liquid. You put the baking soda with the vinegar, it's in a liquid solution, but it forms a gas, and then you see all those bubbles. So that's called a gas evolution reaction. There's chemical reactions happening in your car. Hydrocarbons. Gasoline contains a whole bunch of different hydrocarbons. Octane is one of them. It combines with oxygen from the air and forms carbon dioxide and water. And in the process of that octane burning, you get a lot of energy being generated. There's enough energy to move your engine, which moves your car. And that is a combustion reaction. We're going to learn about different kinds of reactions. So that's a combustion reaction. It's a subcategory of oxidation reduction reactions. And we'll talk more about those later. But again, we've got substances reacting together, and they're forming different substances. That's the heart of a chemical reaction. Laundry detergent. There's chemical reactions involved. Here we're looking at soap in pure water and in hard water. Soap is much soapier in pure water or soft water. And in hard water, you're not going to get as much foaminess. And that's because the ions in the hard water react with the soap. So we've got dissolved calcium and magnesium ions, and they interfere with the action of the soap. They react with it and form a gray, slimy substance called curd or soap scum. So if your clothes are getting dingy and gray in your wash, it's because of the hard water. It's a chemical reaction. Laundry detergent works better because it's got sodium carbonate in it. Sodium carbonate is going to react with the calcium and magnesium ions and get rid of them. Form solid calcium carbonate and solid magnesium carbonate, and those are going to settle to the bottom of your laundry mixture and they'll be removed and then the soap can do its thing. This is an example of another type of reaction called precipitation reactions.